Hello, my name is Bilal Algazaly, and today I will be discussing the Balking design pattern for my CIS 476 course. So what we got on the agenda is to go through the intro, the intent and applicability, pros and cons, UML classes, and then at the end I'll be showing you a demo and implementation of the design pattern. Intro to Balking. The bulking design pattern is a software design pattern that is used in situations where an object should perform a certain operation only when the system is in a particular state. If the system is not in the correct state, the object should balk or refuse to perform the operation. The bulking pattern is often used in multi-threaded applications to ensure that threads only execute certain operations when it is safe to do so. So, as an example, we could imagine that there is a thread that needs to update a shared resource. Before it could update the resource, it needs to acquire a lock. If the lock is already held by another thread, the updating thread should not wait for the lock but should instead bulk and return without modifying the shared resource. Intent and applicability. So the intent of the bulking pattern is to utilize to stop an object from executing particular code if it is in an unfinished or unsuitable state. The applicability. If an object is invoked while it is still in an inappropriate state to execute a method, the control should be returned promptly with an operation with an appropriate indication. So advantages and disadvantages. So for the advantages, it helps to avoid unnecessary processing and reduces contention for shared resources in concurrent programming scenarios. It also improves the performance and efficiency of concurrent systems by avoiding unnecessary processing. It helps to prevent errors and ensures that methods are executed only when it is appropriate to do so, which can improve the quality and the reliability of the system. It also can be used to implement efficient and effective synchronization mechanisms in concurrent programming scenarios. So some of the disadvantages is it could potentially result in missed opportunities to process actions that are actually needed. This could cause delays or errors in the system. The bulking pattern could make the code more complex, particularly when dealing with complex state transitions or dependencies. It may introduce additional synchronization overhead and reduce concurrency, particularly if locks are used to ensure threat safety. So is bulking an anti-pattern? So the more I did research on this is I seen that there's two sides, both with great points, two sides of the arguments that in fact there's a anti-pattern, and some will argue that it is a design pattern. So just to go over that, the bulking pattern is a design pattern that is used to prevent an action from being performed when certain preconditions are not met. While it can be useful in some cases, there are arguments for it being an anti-pattern in certain situations. So just to summarize, some of the situations could be uh, adding unnecessary complexity, reduces flexibility, affects performance, makes debugging difficult, or violates the single responsibility principle. Bulking pattern UML class diagrams. So for the UML class diagrams, I provided two different examples just to show the diversity of the UML class diagrams. So as you can see, the UML class diagrams are fairly simple. On one hand, we have two classes, and on the right side, we have a single class, which is what I used for my demo that I will be showing after this. So I'm just gonna go over the worker diagram. So in this diagram, the worker class has a composition relationship with the task class, meaning that the worker object cannot exist without a task object. The task class has a state attribute and a lock object, which are used to maintain the state of task and synchronize access to the state attribute. So this is the UML diagram class I will be using for my demo. So just to go over the class, in this example, we have a printer class that has two private attributes, printing and lock. Printing is a Boolean variable that keeps track of whether the printer is currently printing a document or not. And lock is a lock object that we use to ensure thread safety. And then print document returns a string and lets user know once um, the processing of a document has been printed, and it could return either two different types of messages, which we will see in the code that I will show right now. Demo time. Okay, so this is the code that implements the bulking pattern. As you can see, we imported threading and imported time to use that, to have that into use for some functions such as sleep and all that. So as you can see, the printer class has a single public method called printDocument, which takes a string argument representing the document to be printed. The method uses the bulking pattern to check if the pattern is currently busy before printing the document. If the printer is busy, the method prints a message, right, indicating that the printer is busy and returns without printing the document, which we can find right here. If printer is not busy, the method prints the document and simulates a printing job by sleeping for 5 seconds. It was implemented right over here. To test the functionality of the printer class, we created a instance of the print document method. Then we created two threads simultaneously to print documents while the printer is still busy with the first document. Since the print document method uses bulking design pattern to prevent printing, if the printer is currently busy, the second and third documents are not printed and the threads complete without any error. So let's go ahead and give this code a run. Okay, so as you could see, the printer started printing document 1, and as it was printing document 1, document 2 also wanted to be printed. So part of the implementation is that, remember, it bulked the document 2, hence returning the message to the user that printer is busy, document cannot be printed. But eventually, once document 1 was finished printing, document 2 was also printed successfully. Go back to the slides. Okay, overall, the bulking pattern, which is a behavioral pattern, I did not mention yet, can help to ensure that the system operates correctly and efficiently by only performing operations when they are safe and appropriate to do so. So a nice way I like to think of this, kind of in layman terms, is the bulking pattern is almost a special way to make sure that we don't do something too early or when it's not the right time. So you can imagine you have a cookie jar and you really want to eat a cookie. But if you see that the jar is empty, you would not try to take a cookie because there is no cookies. That's like bulking. You're waiting until the cookies are in the jar before trying to take one. So basically, the bulking pattern is waiting until the right moment to do something instead of doing it too early or when it's not the right time. Here are some of the sources I have used for my research. Feel free to check them out. They are great sources if you would like to take a deeper dive. And to conclude, thank you for listening, and I hope I helped you at least understand the basics of the bulking pattern and its implementation and when it is useful in certain scenarios. Thank you very much.